A rational number is a number that can be written in the form a over b, and where a and b are integers and b cannot be 0. Now with any fraction, the denominator can never be 0. You can type in your calculator something over 0, say like 2 over 0, you probably get undefined or maths error. So make sure denominator is never equal to 0. That's what it's talking about here. And a and b must be integers, so it can't be decimal numbers, it can't be fractions or anything like that. It must be an integer over an integer, like a whole number, okay? Now, the reason why I wrote a over b is a fraction, isn't it? So a rational number is a convertible number. So if it's a decimal number, it should be able to change that to a fraction form. So have a look over here. A rational number could be 3, 4.5, 0.001, 4 on 5, these numbers over here. Now these numbers, you can convert them to, if it's a fraction, you can convert it into a decimal. If it's a decimal, we can convert it into a fraction. And it's a whole number, isn't it? Whole numbers are always rational. 3 is 3 over 1s. We can write it in the form a over b, can't we? So that's a rational number. 4.5, we can change that into a decimal, can't we? And these ones, they're all convertible. It's not going to be, it's not fixed as that, is it? We can change it into a fraction. Now, recurring numbers are also convertible. We can change them into fractions. But have a look at these irrational numbers. These numbers such as 2.34087, blah, 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 it's infinite, it goes on forever. We cannot convert these into decimals, fractions. Pi, you know that pi is 3.14, blah, 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 it goes on infinitely. This is unchangeable. You can't change this to a fraction, so this one is irrational. Root 2. 2 is not a perfect square. We cannot change this into a decimal into a fraction, because this one is something like this. It goes on infinitely. Okay, so see how these numbers, they are unchangeable. That's why they are called irrational numbers. So do you kind of get the difference? So this is very important in Surds, so make sure you know the difference, okay? Now I'm going to go on to Surds. Surds, you'll see a lot of roots. Okay, so think about this, guys. Surds equals to roots. Now have a look. Root of a certain number x is the positive square root of x. Okay, so it must be a square root of something that's positive. Okay, so this one is positive number. It can't be negative, so x must be greater than 0. So remember, the inside of a square root must always be positive, right? And if square root of x is 0, x is always 0, because square root of 0 is always 0. Okay? Now, square root of x is undefined if x is less than 0, which means if x is negative, this is undefined. We can never square root a negative value, so always remember that, okay? Now, to go on a little bit more specific, square root of 0 is 0, because 0 squared is 0, isn't it? This one is not a surd. Now, surds, have a look over here. Square root of 1, that's 1, isn't it? Because 1 squared is 1. So this one is also not a surd. Now I'll show you why in a second after I do some comparing. Have a look at root 2 though. Root 2 is 1.4 blah, 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 blah. This is a surd. So can you kind of see the difference, guys? Square root of 1, we can simplify that to a non-root number. It's 1. So we can get rid of the root, right? But root 2, if I calculate this, it's something like this, right? So in exact form, I have to keep it as root 2, right? This is not exact. It goes on forever, so I can never write it exactly as it is. So if I wanted to write it exactly, I'll have to keep it as root 2, right? So see the difference. 1 is not a surd because I can get rid of the root. But root 2, if I want to keep it as an exact form, I cannot get rid of the root. I have to keep the root there. That's why it's a surd. So surds, it always has the root. So those involving the root is a surd. Have a look at the next one, root 3. Root 3, if you calculate that, it's going to be something like that. Again, 3 is not a perfect number, so we cannot get rid of that root. We have to keep it as root 3 in order to keep it in an exact form. That's why this is also a surd. Do you get the idea, guys? That's the difference. So have a look at this one, root 4. 4 is 2 squared, isn't it? So I can get rid of that root. It's going to be 2. Root 4 is 2 because 2 squared is 4. So that's why this one's not a surd. It's because we can get rid of the root. Okay, that's how you compare the difference. That's how you can determine if it's a surd or not. Okay, not too hard, yeah? So root 5, we'll do another one. It's something like that if you calculate it with your calculator. And root 5, we can't make it into an exact form without the root. So root 5, we keep the root there, so that's why it's a surd, because the root will always be there to keep it as exact form. So that's the whole idea. These are not surds, these are surds, but you can clearly see the difference, right? Now let's try the questions. Starting with question 1, we're going to state whether the following numbers are surds or not. So, root 6, calculate that. Use your calculator. You should get something like this. Now, is that a surd, guys? Yes, it is. It is a surd. So I'm going to put a tick under the surd. So, this one is not an exact form. We can't get a whole number. We cannot get an integer. So that's why it's just root 6 as the exact form. We have to make it, it is a surd, okay? So therefore it is a surd because we need the root there. Now B, root 9. Guys, we can simplify this, can't we? We can simplify this to 3. Now 3 is a whole number, it's an integer. That's why we can say it is not a surd, okay? Because the root can go away, all right? Now C, negative root 7. Okay, well negative, we can keep the negative there, but have a look at the root 7. Can you guys calculate root 7? Well, root 7 is 2.6 something, so it's negative 2.6 something here. So this one is not an exact form, it's not an integer, therefore it's a surd. Okay? And then D, root 49. Guys, everyone tell me what root 49 is. Should be 7, because 7 squared is 49, right? So therefore this is a whole number, it's an integer, therefore it's not a surd. Okay, that's pretty much the idea, same as what I've explained before. And E, okay guys, I hope everyone can tell me if the value of this one, square root of negative 4. Or guys, can you tell me, can we square root a negative number? I think I've said before that we can never ever square root a negative number. That's why this one's undefined. As soon as you see a negative inside a square root, make sure you can automatically say it's undefined, okay? So therefore this one is a surd. Okay. Oh, sorry, it's not a surd, sorry. Because it's not, we can't say it's a surd or not because we can't make it into an exact value. It's not an integer, it's not a value. That's why it's not a surd. Okay, surds, we have to always keep the root there to make it in exact form. Okay, and that's pretty much the idea. So I hope you can kind of see what the difference between a surd is and not a surd is again. Now F again, this one, put this in your calculator and check. You're going to get 5.2. Now guys, ask yourself, is 5.2 convertible into a fraction? Can we change that into a fraction? Yes, it is. So therefore this is also not a surd because we can get rid of the root and we can write it like that as an exact form. It doesn't go on and on infinitely. So that's why it is not a surd. Okay? That's pretty much it. So even if it's a decimal, it can also not be a surd as well. Now G, cube root of 25. Guys, again, calculate that. We can still have cubes with surds. That's going to be something like this. It goes on infinitely, so it's not convertible. So therefore, it's not an integer. Therefore, it is a surd. Okay, so surds are irrational, basically. Okay, and non-surds are rational. You can think of it that way. Question 2, state whether rational or irrational for the following numbers. So 0.31, can we convert that into a fraction? Of course we can, it's 31 over 100, isn't it? So therefore this one is rational, okay, because it's convertible. Now 0.1111, guys, do you know what the fraction for this one is? It's 1 over 9. Check 1 over 9 into your calculator, you should get that as a decimal. So therefore it is also convertible, therefore it's rational. Okay, so usually recurring decimals are always rational because we can convert them into fractions. Now see, that one, it goes on, you can clearly see that the ... indicates that it goes on infinitely and there's no strict pattern, so therefore that one is impossible to make it into a fraction, that's why it's irrational. Alright? And D, 4.2%, that's 42 over 100, 4.2 over 100, isn't it? And you can convert that into a decimal of 0.042, which is 21 over 500 as a fraction. So you can clearly see we can make it into a decimal and we can also convert it into a fraction. That's why it's rational. Okay, so just convertible. If they're convertible, always rational. Question 3. Let's state again if it's rational or irrational. 7, is it as a decimal number? It's just 7. Well, it's just 7.0. You can just write it as 7. This one is definitely rational. Now 0.44444 is a recurring decimal. Now as a decimal, I know that as I said it's that, and remember how I said recurring decimals are always convertible into decimals or fractions. So this one is also rational. Okay? What about root 10? Calculate that one. You should be able to get this number in your calculator. And again, its root 10 is an infinite number. It goes on forever after the decimal point. That's why it's not convertible. This one is irrational. Okay? So therefore, is it a surd or not? It's definitely a surd, isn't it? And D, 5 root 3, root with the 5 power. That one, calculate it. You should get something like this in your calculator screen. And guys, tell me, is it rational or irrational? Definitely irrational. It goes on infinitely after the decimal. It's not a rational number. Question 4, state whether rational or irrational again. Now, root 2 over 2, guys, again, calculate that in your calculator. You should get something like this. And guys, tell me, is it rational or irrational? It must be irrational. It goes on infinitely after the decimal point. Okay, we can't change that into a fraction. 1 over root 3, again, calculate that and change it to a decimal number. That's what you should get. Again, it's a very similar one, must be irrational, okay? Pi on 2. Pi on 2, put that into your calculator and you should get something like this. Again, irrational. Now, anything involving pi's, usually it's irrational, okay? Pi itself is an irrational number because it's going on infinitely. There's no strict pattern, so we can't convert that into a fraction. So, pi on 2 must also still be irrational. 2 on 11, guys, change that into a decimal. You should get something like this, 0.181818, so it's a recurring decimal. Recurring decimals are always convertible, so it's always rational. Okay? Question 5. Okay, we're going to arrange this group of numbers in ascending order. So what does ascending mean, guys? Ascending is simply from smallest to largest. So we have to find which one is smallest and which one is largest, right? Now this one is all in different types. Some of them are square root, some of them have decimals, some of them are pi, so we have to convert them. I'm going to convert them all into decimals so I can compare them really easily. So starting with the root 11, that's 3.31, isn't it, as a decimal? Now 3.2 is already in a decimal, so I won't change that one. Now pi, it's 3.14, yeah? And 2 root 3, that's 3.46, something. And now let's compare. Guys, which one is the smallest? So out of that, this, and this, which one is the smallest? You can clearly say it's this one, pi. Pi is the smallest. Now, you can see that the second smallest is a 3.2, and then it's going to be the 3.3, so root 11, so that's number 3, and that one is finally the largest. So if I put that in order, it's going to be from pi, 3.2, root 11, and then 2 root 3. That's the answer in ascending order. Can you see it? So if it was going from largest to smallest, what would it say? Must be descending, isn't it? So make sure you remember these terms. Question 6, between which two consecutive integers do root 5 lie? Okay, so what this means is we have to find the integers in which root 5 is in between. So root 5, first of all, convert that into a decimal so I can see what this number is. It's going to be 2.23 something. And you can see that 2.23 is in between which two integers? 2 and 3. Okay, it's between 2 and 3, isn't it? Because if I draw a number line, if this is 2 and this is 3, 2.23 is approximately here, isn't it? So it's in between 2 and 3. That's why we write it like that. Okay, that's pretty much all there is to it. So it's very simple. Easy question. Root 7 is a similar thing. Which two integers are in which negative 2 root 11 is in between? So again, calculate that one. Negative 2 root 11 is something like that if you calculate it with your calculator. So negative 6.6 is in between. Think about it, guys. Negative 6, or negative 6 is here, and then it's negative 5, and then it's negative 7, negative 8. Negative 6.6 is approximately here, isn't it? So it's in between negative 7 and negative 6. So negative 7, negative 6. So you can draw yourself a little number line if you ever get confused. Okay. Question 8. Write all integers between these two numbers, root 10 and root 50. So again, we're going to figure out what these numbers are first of all. So root 10 is 3.16 and root 50 is 0.07106. So again, I'm going to draw up a little number line. I'm going to start from 2, 3, 4, 5, 6, 7, maybe 8. I think that's enough. And root 10 is 3.16, so it's over here somewhere. That's root 10. And root 50 is 7 point something, so it's over here somewhere. Oh, sorry, 50. What am I doing? Sorry. Okay, so the numbers, the integers between these numbers are 4, 5, 6, and 7 as well, isn't it? Because root 50 is slightly to the right of 7. So therefore, 4, 5, 6, 7 is the solutions. Okay, so again, draw yourself a little number line and you can see the answer really straight away. Alright, so that was 8. Number 9, similar question. Again, we want to find the integers between negative root 5 and 2 pi. Again, just calculate it, guys, so I can see what those numbers are. If you put it in a decimal, it's really easy to determine it. So, negative root 5 is negative 2.2. And 2 pi is 6.28, isn't it? Again, draw yourself a little number line. I'm just doing this for those who can see it better with the number line, like me. I always find it better to see with the number line. Now, negative 2.2 and 6. So it's going to be, I'm going to start from maybe negative 3, negative 2, negative 1, 0, 1. Make it a little bit longer. 2, 3, 4, 5, 6, 7. Is that enough? It's a big number line, isn't it? And negative 2 is negative 2.2 is approximately here, isn't it? And 6.28, it's approximately here. So all the integers between these two numbers are this, 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 all of these. So quite a few here. So write them down. So starting from negative 2 all the way up to 6, these are all the integers between those two numbers. So it's a bigger set, isn't it? That's pretty much it, guys. So hopefully you understood what the difference between rational and irrational numbers are, and also surds and non-surds. Okay, so that was the end of this first part.